All right, chapter 4 was short, but we're wrapping it up right now. So we're gonna do real world similarity problems. And that's like finding the heights of something using indirect measurement. Let's talk about some examples. All right. Now, all of these are kind of, they're all different, but they all have the same sort of feel to them where they're talking about shadows. The other option is that there's somebody looking at a mirror at something else, and you can figure out how tall it is from that just by the distance of the mirror is from the two different things. It's morning time. The cats are excited. So a flagpole casts a 50-foot shadow. At the same time, a woman who's 5'4" standing nearby casts a 40-inch long shadow. How tall is the flagpole? I'm going to just hold on. Skip ahead 30 seconds if you don't want to hear this, but my cats growl at each other when they have toys, and that was his growl. So I kicked him out. Okay, I just want to recap that this little 1 symbol means feet. This 2 of them means inches, just in case. And it's very important that it's happening at the same time because the shadows are caused by the sun. And if the sun has set 30 minutes, it's going to be a longer shadow, right? It's how the sun is coming down. And so it is very important that this says like at the same time, someone nearby. I can't measure a flagpole based on my location in like Nepal. It's just not going to work. Like I have to be there at the same time. Okay, so we're going to figure out how tall the flagpole is. Some of you are visual learners, so I'm going to draw a picture in case you're a visual learner. You don't have to draw it with me if you don't want to. But let's see. So over here is the flag pole. We'll just assume that there's a flag on it. You can draw whatever kind of flag you want in here. I don't care. And then the sun, right? Sun's shining up in the corner. And so this casts a shadow. And then there's a lady. I'll put her in a dress because I'm being a terrible person right now, who also casts a shadow. Not terrible person, just anyway, it doesn't matter. Okay, so there's my shadows. And it says that this woman is 5'4". It says her shadow is 40 inches. This is going to be key later, is that this is all in weird things. And this is a 50-foot flagpole, not drawn to size. So what we have to do right now is actually turn everything into either inches or feet. It doesn't really matter. The common one is to turn everything into inches. So a key here is that there are 12 inches in a foot. Okay, so my first option is that I can multiply 5 by 12 and add 4, and multiply 50 by 12 and not add anything because it's just that. So hold on a second. I lost my calculator. Okay, so 5 times 12 is 60. So this is 64 inches. And then 50 times 12 would be 600. So this is 600 inches. And this is still 40 inches. It's already in inches. Okay, but we actually kind of want to keep the flagpole in feet. Oh, wait. Sorry. This is the shadow. Not the flagpole. We don't know the flagpole height. Okay, sorry. I'm sure you yelled that at me like 20 minutes ago. Not 20, 3 minutes. It's only been 3 minutes. Okay, so that's the shadow. Fixed it. Now, I'm just going to say that if you want to turn these into feet, it's really common for people to want to go that 5'4" is 5.4 feet. That's not true, okay? Because that is assuming that we have a base 10 number system for everything, which we don't. Inches and feet, we don't have base 10, right? It's base 12. It's out of 12, not 10. And so in order to find this, I can do 4 out of 12, which is a third. So 5'4" would be 5.3 feet. I shouldn't have done the thing there. Hopefully that makes sense. I don't know. So if you want to turn everything to feet, you could do 40 divided by 12. This would be 5.3, and then this would still be 50 feet. It's your call. I don't care. Okay, so I'm going to keep it the way it is because I already used the information. Now, these are similar triangles because I have this sunshine just streaming down, right? The sunshine's causing these triangles, and I know that the angles are the same. even though they don't really look similar with my drawing right now. Don't judge me for it, okay? It's because I made the shadow longer than her. That's why it looks weird. Okay, but the angles are the same. So I have angle similarity, which means that I do have similar triangles. So because these are similar triangles, I can do proportions. So I can do, let's say, height over shadow. So I can do 64 over 40, height over shadow, equals height. I don't know the height of the flagpole, but I know the shadow is 600. And then I just cross multiply and divide. So it'll be 64, okay, 40 times x equals 64 times 600. I don't know what 64 times 600 is without my head. Of course, 40x equals 38,400. Why didn't I know that? Divide by 40, that is 960. All right, so x equals 960, which is not the final answer. So x is 960 inches, right? Because everything I did here was in inches, so my answer is in inches. But I don't need to know how many inches a flagpole is tall. I kind of care about feet. Plus, it gave me the flagpole's shadow in feet, so let's turn this into feet. So to turn this into feet, I would divide by 12. It's just a 2 there. So 960 divided by 12 would get me 80 feet. And whenever, this is not new, whenever we have a math problem in words, we answer in words. Every time. Welcome to the real world. Okay, let's do one that I was kind of talking about with that mirror. Okay, so let's do another one. Plus I have space. Okay. Before rock climbing, Darius wants to know how high he will climb. He places a mirror on the ground and walks backward until he can see the top of the cliff in the mirror. How tall is the cliff? There's no numbers in here, so let me draw the picture for you and add the numbers to the picture. Okay, so here's Darius. He's 5.5 feet. That's not 5 foot 5 inches. That's 5 foot 6 inches because half of 12 inches is 6 inches. Follow me for more real world tips. Okay, and then so basically what's happening is he's looking down into the mirror and the mirror is reflecting back to the cliff. These are similar because this angle right here, remember that proof that we did in the first one nobody did because it was scary because it had science in it? I think it's a law of reflection. Says that these two angles are the same. And then these are right angles because he's standing straight up and the cliff is straight up. Okay, so we have to figure out how tall the cliff is. Even if the cliff is kind of curved, we're going to assume it's 34 feet from straight down from the top of the cliff. So these are similar triangles, right? Boop, 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 boop. It was the same up here too. The angle from the sun here, it doesn't actually matter which angle it is, but it's the same. Okay, so these are two similar triangles. We have to figure out how tall the cliff is. And then just in case this is too small, this is 5.5, 6, and 34. Okay, well, I can do the same thing I just did. So I can do, so this is the distance. He paced out the distance away from the mirror and the distance away from the cliff. So 5.5, so I'm going to do height over distance. It's kind of like height over shadows. But the cool thing is that this is all already in feet, so I don't have to translate anything. Yes. Okay, but I have to be careful here because I want the height. So I don't know what the height is, and it's over 34. So then again, I'm going to cross multiply and divide, so I get 6x equals whatever 5.5 times 34 is. Do I know? No. 6x equals 187. And that won't divide by 6 nicely, but it'll get kind of close. So then x equals 31. We'll just say 31.2 feet. It's 31.16666666. Okay, but again, that's not the final answer because if it asks me in words, I'm going to answer in words. So Darius will climb about 31 feet to the top of the cliff. To be honest, I should not have included this symbol. I should have said about, and I shouldn't have included the feet symbol. I should have said feet. That was my bad. It's fine though. Also, last time I probably should have said the flagpole is 80 feet tall. Oops. Oh well, we're fine, we're fine. Okay, so again, if it asks in math, if it asks in math, answer in math. If it asks in words, answer in words. Pretend like they don't know what this means. Use your words. Okay, I hope this helps. Hope you answered all your questions. If not, email me. We're gonna do some more problems like this. Not a lot, because it takes a lot, but we're gonna do some. Okay, see you later.